Okay. Hello, Catharina. Happy birthday from Georgia. Best wishes.
Thank you.
Thank you very much. Okay, you can start.
Okay. Well, unfortunately, I can't see you, but hopefully you can see the presentation too.
Yeah. Thank you.
Okay, great. So I will give a first introduction about the potential of blockchain in the energy sector. So when it comes to blockchain in the energy sector, we talk more about the technology itself and not a lot about the cryptocurrencies. We might talk a little bit about tokens. To give a first introduction about myself, I come from a more traditional energy sector. I was working for utility companies doing energy efficiency projects, so more on the technical side and of the energy sector than on the technological side, until I realized that digitalization as a whole can really bring energy transition forward. And with digitalization, I also understand decentralized business model powered by blockchain. I will give like a short introduction about the challenges of the energy sector today so that you understand where blockchain might fit in. And in fact, we have several key trends in the energy sector that are completely reshaping the face of the energy system, but also opening the way for new business models. Electric vehicle cars, for example. In Germany, by 2025, we expect 3 million e-cars. This is setting energy suppliers and grid operators in front of new challenges. The digitalization of the energy system. The fact that we put IoT devices into households giving real-time information about consumption and production, opening also the way for new business models. The decentralization of the energy system. In Europe, growing by 8% every year. And by that, we understand decentralized power plants from companies, but also the fact that people are installing also their own power plants with a photovoltaic panel on the roof or a little wind turbine, and become what we call prosumer, private people producing electricity. And those trends, we can also explain them in a more global aspect. Because when we talk about energy, we do not only talk about a commodity that is being produced, traded, and distributed, but we talk about politics, we talk about economy, we talk about infrastructure, and we talk about people that are willing to share their car, their bikes, their homes, and also their electricity. Those trends, we call them the 4Ds. The decarbonization, the decentralization, digitalization, and democratization. And with that, we understand also the fact that we could enable people to sell and buy the electricity directly in a very secure and scalable way, and with a very high degree of independency. And that changes a lot of things, and it's exactly where blockchain started to make sense for the energy sector. On the electricity market as a whole, we can understand two tendencies. The first one is a fundamental decision for an energy-only market. And the other aspect is a capacity market. And this approach hits the challenges of the energy transition. So when we talk about the electricity market, we should promote decentralized power generation and also the proactive participation of consumers in the electricity market as prosumers. So digitalizing the energy transition will not only enable consumers to participate in the electricity market, but also increase flexibility of demand and supply. I will give a few examples. This is exactly where blockchain can play a role. Blockchain can play a key role by bringing decentralized supply and demand together in an automatic way. And more precisely, it could be able automate the interaction between generation facilities and consumer devices. Beginning 2015, blockchain hit the energy sector by storm. And one of the questions that we get asked all the time since then is if blockchain only is a hype, or if it's going to put the whole energy sector on its head. So don't be scared, it's not going to stay white. I have an answer to that question. And in fact, the blockchain is, for the energy sector, facing a lot of hurdles. Regulatory hurdles, technological hurdles, the fact that the energy infrastructure isn't as digitized as it is. And it is complicated to build a completely decentralized system. And this is what we expect from blockchain, a completely decentralized system. But it can also be applied into other applications, like building a pool of saved electricity and supporting community energy models. Bringing together operators of renewable energy assets and their neighbors willing to buy electricity, green electricity locally. Helping reducing congestion measure costs by integrating more renewable electricity in the system. There's a lot of projects today at hitting the energy sector and giving an overview of how a future energy system would look like. And to understand those trends, at PwC, we developed blockchain energy radar. We started quite early in the context of the first study that we published in 2015 to screen all the initiatives around blockchain and energy. And in the first year, we found like 15 initiatives, mainly driven by startups in the blockchain energy space. And only 2 years after, there were over 100 of initiatives worldwide. So before I give a few examples of those initiatives, I would like to recall the reason why. For a couple of weeks, I had lunch with a friend of mine who's working in an oil and gas company, and I wanted to know what they do with blockchain. And she said to me they have already a team of 16, 17 people only working on potential use cases where blockchain would make sense for their company, both internally but also for their customer, and also for their operations. Why is it so that so much companies, startups, are flourishing and focusing on blockchain application for the energy sector? But because the decentral blockchain model would let us imagine an energy system where some of the main actors, energy suppliers, metering companies, banks, traders, will not become redundant. This is a mistake that we did also with the internet, but they will have to play another role. They will have to reposition themselves in the market. And also one very important aspect when it comes to digitization as a whole, they will have to close the last mile to the end customer. And this is something that we see in one initiative driven by Innogy. Innogy is the ecological sister company from a big German utility, RWE, and they launched a startup called Conjoule for 2 years, who developed a decentralized platform on Ethereum, enabling residential photovoltaic owners to sell their surplus of electricity generated by the photovoltaic owners to the consumers in their region. So enabling peer-to-peer transaction on retail of energy in 2 regions in Germany. Why would they do so? Why would an energy supplier cannibalize themselves? Well, to answer that question, we have to look at the regulation. In Germany, we have a very complicated regulation. I know that in Georgia, when it comes to the energy market, it's quite different. So it's kind of a luxury, actually, because you have much more freedom to innovate than in other European countries. In Germany, if you're a private consumer of renewable energy assets, you do not have the right to sell as a private consumer, as a private person, your surplus of electricity, your electricity. But you can obtain that right by registering as an energy supply company, by building a balancing group, by doing a lot of energy-related jungle book aspects that are way too complicated for a private consumer. When we present all those steps to consumers, they kind of look at us and say, I'm sorry, but life is too short. And so that's one of the main reasons why Innogy, as an energy supplier, can position themselves on the market as a service provider for the end customer. Building that platform, offering that platform, and enabling one thing that is actually only able with blockchain, having a traceability of all the kilowatt transactions that are done between a private prosumer and a consumer, which is an important data for the supplier. They have transparency and control of all the electricity that is generated in one region. Also, they can reduce costs, because if the energy stays locally, they have the potential possibility to be much more independent from the higher grid level and reduce electricity transport costs. So they kind of having a nice business model by offering something more than the regular feed-in tariff and having more green electricity in the system, reducing costs. And this is not the only initiative in Germany. Maybe we can argument on the fact that they could use blockchain with a lot more potential. But for now, the business model that they build on top of it completely redefines the way market participants are interacting with each other. And this is also something that we do with the TWL, which is a regional utility in Germany called actually Technische Werke Ludwigshafen, so you do not have to recall that name. But it's a project that we're running at PwC in Germany. And what we do is a virtual auto-balancing microgrid. We have, that microgrid is a set of, as you can see, B2C prosumers, so having photovoltaic panels on the roof, B2B consumers, supermarkets, there's a hospital, quite intensive manufacturing company in the region. We have local solar power producers owned by the TWL, and a storage station. In all the participants of that system, we introduced IoT metering devices. Those IoT devices, they act as a light node, collecting information about production and consumption every 5 seconds. Those light nodes, they send over those information to one full node, a Raspberry Pi, that is in the office of the TWL and that writes all the transactions into the blockchain. They feed smart contracts that manage the flow, and smart contracts that actually balance that auto-balancing microgrid by matching supply and demand within that network. What we're proving is that blockchain is enabling us to completely automatically balance supply and demand within that microgrid, so in a small region in Germany. We are facing troubles, of course, with the regulator, but as I said before, I think energy laws are not natural laws, so if we build the right business model, if we have the right idea, if we use blockchain where it actually makes sense, then also the regulator will adapt. For that, I'm quite positive. I have another example that I really like, where we use an energy token. On that picture, you see the community of Düsseldorf. It's in Amsterdam, in the Netherlands. You see photovoltaic panels on the roof of those installations. You have building offices, a restaurant, a cafe, a bed and breakfast, a greenhouse, and they're all connected by a private behind-the-meter smart grid. So when it comes to the infrastructure, they have the possibility to exchange surplus of power that is generated from the photovoltaic panels. And how do they pay for that electricity that they exchange? Well, in a normal energy system, when you consume your electricity, the energy supplier collects the information out of your meters, smart or not smart. They generate an electricity bill. They send it to their customers, and the customers are paying, and the transaction goes, monetary transaction goes from a bank to another bank. In that case, it's a little bit different. They launched an energy token called the Juliet, because of the joule, helping people to pay for that electricity with the token. So it means that the transaction goes from a virtual currency wallet to another virtual currency wallet. So they're both bypassing the energy supplier. Not always, the sun has to shine, and they're certainly bypassing the bank. To do that in the regulatory framework, they have the possibility to use a sandbox. A sandbox is the possibility to express your innovation in 10 years or 5 years that you can require in certain countries, and in Amsterdam they have an innovation freedom for 10 years. If that succeeds, maybe the regulation will also adapt. What I want to express with that example is that blockchain in the energy sector doesn't only enable people to exchange the surplus of power, because with that token they can also trade for goods in the Düsseldorf cafe or in the restaurant. They can integrate other community, intra-community service like a car sharing program. They have the possibility to build a circular, positive, and resource-based economy. That gives a little bit more proposed to what we can do with just a computer protocol. At PwC, we started quite early to express and analyze what we can do with blockchain in the energy sector. We, of course, have experience when it comes to use case development, when it comes to develop proof of concepts, but as I mentioned with the projects that we are running with the TWL, we also have experience when it comes to the real implementation, looking at the infrastructure, looking at the technology itself, looking also, of course, at the regulation and also at the market. What's the need for the end customer, who, by the way, doesn't care if the platform is based on blockchain or not. This is more an added value for the company. So we do not only bring our solution onto beautiful slides, but we also are able to build it onto complex systems. To those, I don't think there's a lot of blockchain pessimistic in that room, but in the energy sector, there are still a lot of questions regarding the feasibility of blockchain, regarding is it really like, how is it different, or is it more interesting than a shared database? So we always have to explain that, of course, blockchain is a game changer. On the technological side, it's not only a hype because it contains validated proof of all the transactions that are done, and not on one central server, but on all the participants of the network. So when it comes to a more decentralized energy system, blockchain makes sense. But for that, we have to decentralize power generation. And to those who might still be a little bit pessimistic, I like to ask if you remember the first version of Amazon, or how internet looked like for 10 years ago or 20 years ago. It changed a lot. When someone asks me if blockchain only is a hype, I like to answer that blockchain, of course, is going to be an underpinning accepted standard, like the TCP/IP standard 20 years ago, and it has the potential to change the way parts of our societies and organization operates today. When it comes to blockchain in the energy sector, in European countries, it helps us to manage and control data in a very transparent and tamper-proofed way. It helps us to build processes way more efficiently than we did before. It also helps us to have transparency and control of all the system. And of course, it helps us also to reduce the costs. But think about what we could do with blockchain in developing countries, like in countries where the energy costs sometimes represent more than 40% of the cost of one household. If we had the possibility in those countries to bring renewable electricity locally at lower costs with a more stable system, we would actually enable, for example, more girls to go to school and have proper education. We will save lives by preventing blackouts. That gives a little bit a better overview of the good things that we can do with blockchain technology. Thank you.
Thank you very much for your participation.